All right, so today we are going to switch gear from doing all the differential equation based computation to start doing data based computation. All right, so how many of you have done data analysis before? Almost all of you. Okay, so can we just have a go around the room and just to tell me what kind of a data analysis have you done before?
I've done some like auto or like not really auto diff, but like estimates. Like you had an input set of data and you had like estimate its differential and then like or it's like derivative and then like fit that to a curve.
So you have some inputs and you need to fit that to a curve.
Yeah, it was like that's like probably the most complicated I've ever done was like you had input data of like say like x position, and you had a model for like the velocity, but like the position function was like not easily accessible, and you had like some parameters in the velocity function that you were looking to like experimentally verify or experimentally determine. So you like took this position data, did like auto differentiation, and then fit that to the velocity model you had.
So basically tuning some parameters in a velocity model.
Yep.
And based on to figure out what parameter would make the parameter model or would make the velocity model match your experimental data the best.
Yes.
Is that right? Okay. Cool. So that's a good example of a data analysis. What else have we done before? I think,
just class projects. I think some intro programming classes, just some sets. I can't remember what they were.
Okay, all right.
I just remember.
Anybody else remember what kind of a data-based computation you have done?
Like, for two of my reps, one of them was data analysis of things that have to do with astronauts' rotation and microgravity. Basically, like angles of how they move there, but the bodies can move, or like times of rotations or things like that. And microgravity to see the easiest way of rotations of astronauts when gravity does not exist, and also data analysis for MOXIE for experiments for carbon dioxide and oxygen production. That's different pressures and stuff like that.
Sounds cool applications, but what are the data?
The data is like different values of pressures at different, let's say, different values of pressures at different percentages of oxygen and carbon dioxide, different percentages of carbon dioxide or oxygen at different pressures and temperatures.
Okay, and what do you want to get out of the data?
To see how the behavior of the sensors or how the behavior of pumps actually is.
I see. Okay. I don't completely understand, but it sounds very cool analysis you have done. So here in the data-based computation section of this class, we're going to introduce a variety of tools for computation based on data. So today we are going to introduce one of the most basic tools, that's a Monte Carlo method. All right, so Monte Carlo method is basically doing things randomly. It sounds like the easiest thing you can ever do is just to randomly do things, right? But how many of you thought of exactly what does it mean by randomly? So if I ask you to randomly come up with a number, what would you do?
Probably open up Python, import rand.
Okay, so that's one of the answer is OpenPython and just type rand.
I mean, it's like it uses like a Mersenne twister, if I remember right, which does like it's like modular exponentiation or something along those lines.
It's interesting. The first example of how do you generate a random number is to actually use a pseudo-random number generator. That's
fair.
which is actually a very deterministic number, but like you can kind of you consider it as random for many practical purposes. How would you come up with a random number?
Literally the first number that came to mind. I mean, a random number is not random that I usually give is like a sale number I remember from the regatta.
All right. So basically what you had is the first number that comes into your mind, which often is kind of the same number, right? That's kind of...
Well, it could be like from an event the last weekend, like a boat that fouled me. And I remember that sale number. So that could be like 10, that could be 24, but it's just...
Which is also actually deterministic, right? I mean, there is actually no randomness in the number. It doesn't like...
set, yeah.
Right.
I've got a better way we could do this.
Okay, you get a better way to come up with a random number.
Take the go get a barometer. Take the like 6th decimal place. Like go measure the like atmospheric pressure outside. Take like the 6th decimal place. And
So take the 6th decimal place of a certain measurement you do, which is almost certainly, unless you like your instrument is extremely precise.
yeah, that's a good.
Otherwise, like the 6th digit is almost sure to be random noise, right? So that's one way of.
I've got one more good one.
Okay.
You have a Geiger counter, and you have some sort of like clock, and like a radioactive source, and obviously like the radioactive, like any particular ping from the radioactive source will average around like some number because it's like on average it's radioactive, but those pings are currently unknown. Like there's no current no known pattern to them other than like that they like decays happen roughly like as randomly as we understand them to be. So the timing between pings could be pretty random.
So the question we are discussing is if I want to ask you to, what does it mean by a random number? So question is, if I want to ask you to come up with a random number, what would you do? So the answer we just had is get a Geiger counter and put it around the radioactive source. And the time between two counts would be pretty much random. And the time actually between two counts is governed by quantum mechanics. And exactly what causes the fluctuation, it's something I don't think anybody understands. The best model in quantum mechanics is that it's random, right? But like what exactly gives that randomness, nobody understands, right? So basically what your answer is to use a mechanism that nobody understands
Yeah.
to produce the number you want. How would you come up with a random number?
Get a coin. And just like make a binary number. Heads is 1 and tails is 0. You just keep doing that like 10 times.
All right, that's another very good way to come up with a random number is to flip a coin, right? Whether it lands on tail or coin gives you, maybe you can put it at 0 or 1. That's a random binary number.